Record. All right, welcome. Happy Thursday. You have your quiz. It'll open tomorrow, but as a heads up, I did post 2 assignments. I would say they're pretty small assignments, but I wanted to break up the probability assignments so that you have kind of the first section and then conditional probability. And so I made it 2 assignments, and they are due next week, but they are good practice for the quiz. So make sure that at least you try those assignments before you go into the quiz, just so you've seen the questions. Let's see if I can. Oh, maybe I'll use one of my fun. Hey, that's what I should have been doing. Quiz. Oops. Quiz number 1. Okay. It'll be available from 8 tomorrow, so Friday until 11:59 Sunday. Okay, it's going to be a 50-minute timed quiz. So once you start, just make sure that you have 50 minutes because you can't go back in. It's a one shot, one opportunity. Okay, so and then make sure that you have an extra 10 minutes after. Just give yourself a little bit of time because you have 10 minutes to submit your written work. Okay, and so I'm feeling confident that I've talked about it already. But it's a 50-minute timed quiz. Okay, and I still have to do the run through, but I'm feeling like 20 questions ish. Okay, but I'm not going to commit to that quite yet because I haven't done the run through. So the 50-minute timed quiz, so just it's going to be 50 minutes. And although you need to keep your pace up, but it's not going to be, terribly, terribly long. So it is reasonable. And I don't like to make it like a huge time crunch or anything, but it is timed and that's stressful, right? That's stressful in itself. And then, and then submit your written work. It'll be on Moodle. So submit your written work as that doesn't say as a single PDF. Oops. To Moodle within 10 minutes of submitting your quiz. So remember, you can start your quiz at any time during the weekend, but then 10 minutes after you've submitted your quiz, you have to have your written work submitted. And the only reason for that is because you can see your quiz after you've done it. And so I don't want you to be working on it, obviously, and submitting this amazing written work. So there's a time pressure there. Okay, so submit your written work as a single PDF to Moodle within 10 minutes of submitting the quiz. Now, the written work is not for marks. Written work is just insurance. Okay, so it's not for marks. It's just insurance. Is just insurance and not for marks. What I mean by insurance is if you go back and you notice that there's an answer missing that you actually did do, right? Then you can message me and say, oh, I have it in my written work. Don't worry, it's there. And then I can go back and I can look and I can give you those marks, right? So it's really just insurance. And so however thorough you want to be or feel like you can be, or if you just want to kind of have it there, it's just how secure do you want to feel with your work, right? If something is missing, can I go back and look for marks, right? Can I give you those marks still? And that's all it is. Okay. And so just keep that in mind. Okay. It does mean that you have to be able to, save your work as one PDF. And lots of phones, and I suspect most of you are still working on, pen and paper. Even though I have an iPad, I would probably work on pen and paper myself, right? And so even though I write on my iPad, I just get old school sometimes. So if you're writing on an iPad or a tablet or whatever, it's easy to save as a PDF and upload it to Moodle, then you're done. If you're writing on paper, you're going to need some sort of scanner, and there's lots of free scanning apps out there. And if you don't have a scanning rhythm established already, what I would suggest that you do is just download all the free ones, right? I wouldn't pay for a scanning app. I found a free one that I like. And so lots of phones have them built in. The iPhone one I don't like. It's kind of hard to use, kind of clunky, but what I did is I just downloaded all the free scanning apps that I could get my hands on. And then I did some test runs just to see how they work. And then I kept the one that I liked. Now I liked Scannable, but it's iPhone only. So if you're on an iPhone, Scannable is really good. And if you want help with that, getting set up, then let me know, because I can definitely do that. But I am kind of assuming that you're all set up already. Let's see here. You've probably had to, hey, I wanted Moodle. I did set up, there's a couple of things here on our Moodle page that I just added. So here, let me see here. Okay. And I'm just going to crop this up here. There. Okay. You can ignore the grayed out ones. Those are hidden from you. So I'll talk about the assignments, like I said, are going to be good practice. Okay. And so, and I think, let's see here. So assignment 3 and assignment 4 are both for probability. Now they're not due until Tuesday and Thursday next week, I want to say, kind of respectively. And so are due Tuesday and Thursday next week. But they will be good practice for the quiz because that material is on the quiz, right? So the reason I extended the due date, so sometimes I'll do it, force you to do it before you do the quiz. But what I wanted to do was just, okay, maybe you haven't perfected those questions, but you feel comfortable solving them on the fly, right? And so maybe you don't have those exact answers, but you want to do the quiz and get that done, and maybe you're banking on the hardest one isn't on the quiz, which it won't be, right? And so just kind of have a look at those, try those assignments, and ideally get them done before you do the quiz, right? Until you're happy with your grade, which should be 100%. And then you'll be prepared for the quiz. Okay, but I wanted to give you more time just in case, things got crazy. So they're due Tuesday and Thursday next week, but will be good practice for the quiz. Okay. So because the quiz is only worth 10% of your grade, we're going to have 4 quizzes, right? I'm not going to do a practice quiz, but the questions are coming from the assignments. So if you feel comfortable with the assignments and the types of questions that I'm asking there, I'm not going to use the exact same questions, obviously, but they will be very similar in nature, right? So think about it as, I'm going to take a copy of that question, and then I'm going to change, the scenario, the types of numbers maybe, and that's really all I'm going to do, right? And so they won't be the same questions, but they'll be very similar. So you'll know how to solve all those problems because they're coming from the assignments. All quiz questions will, I'm going to say, be similar to assignment questions. Okay, so the assignments are good practice. Sometimes those assignment questions are way harder than what I would put on a quiz. So yeah, so the written work, if you are answering a multiple choice question, it's a good idea to just jot down what answer you put, right? And you can, even if they're not labeled A, B, C, D, E, you can just say A or B or whatever, just as a record, right? And so it's just to have a record of the answer that you submitted, just in case it, you didn't click it or whatever, right? Okay, awesome. So I also posted some probability practice, right? That's going to come up for after this lecture, right? Where I have some more practice problems because it's hard. We're limited in time to what we can do. So I wanted to give you more practice problems, and then it got a little wonky because the solutions are actually split into 2 parts, and that's just me being lazy, pretty much. So just deal with it. No, but these are not for marks. Okay, so the probability practice with the solutions are just kind of written answers, right? So these are, whoops, just for practice, not for marks. And then here for the lactose intolerance question, that doesn't mean anything to you now, but it will once you go through the probability practice problems. And if you want to, I actually worked through it in Stat 230 last term. So we're going to move ahead and not have time to do that. And so, but you can look up the video, Stat 230, October 5th, 2021, if you wanted. And it's just at the beginning of that video. So if you wanted to go through that solution, that's where it is. Okay. And then finally, I posted a practice Dropbox for uploading your written work. And so please upload 1 PDF. So that's the only kind of condition. And this is just for practice, not for marks, right? So that's just for you to have a run through before you sit down and do the quiz, just to make sure that you're up and running and you're able to do it, right? So what I would do probably is, if I sit down and I am going to do assignment 3, for example, then I would have it written out properly in my notebook and then go through the motions, right? So put those answers in, write down what the answers are, and then scan my work, make sure I can save it as one PDF, upload it to the practice Dropbox, right? That's just one way that I would make sure that everything's up and running. Okay. Good. All right. A lot of quiz stuff. Any questions about the quiz? I think once we see a quiz, you're gonna, because we haven't seen a quiz yet. So you guys you don't know what to expect, but expect something similar to the assignments, right? And it's going to be in the same kind of, it's called My Open Math, but we just access it through Moodle. So it's in the same module, I guess. I don't know if that's the right word, but anyways. Okay. So, no class tomorrow. No. Yeah. So no video, no class, just you can do the quiz if you want to, right? And so maybe I'll make that a note here. So no class / video tomorrow. But you could, and I'm not saying that you have to, the idea of the 50-minute quiz is that you could use the class time if you wanted to, right? Because that's scheduled into your life. And so, but I'm sure you have kind of a better way of handling it. So no class or video tomorrow, but you could use the class time to do the quiz, but do not need to. Right? Just so you don't feel pressured to write the quiz in that time. Okay. So we did talk about conditional probability. Will the quiz, so the quiz will not be on Zoom. It'll just be like the assignment links. So it'll just be a link that's posted here. I haven't added it, but. So it'll just look like an assignment, but it'll just be called quiz 1. Yeah. And then I'll have another Dropbox for you for your written work. Good. Okay, great. All right. I think we're ready. So, like I said, we started conditional probability, but let's just pretend that we didn't, and let's just start fresh. So I'm not going to call it review, although part of it is. Okay, so we started conditional probability, and maybe I'll just grab the example. I'll accelerate the description though, because we did already talk about it. And this is section 3.2 now, not 2.2, but that doesn't matter. Okay, so, oh, before I forget, right, just a reminder. So the quiz is open book, right? But that is assuming, you're not using, you're not Googling the answers, right? You can Google knowledge, if that makes sense. So if you need to look up, what is the median, then you can Google that, right? But you can't take the question and copy and paste it and find the answer. So you can't use it like cheating websites or anything like that. And you may not use each other. So you're expected to be working alone. And so those are the expectations, but I will write that here. Okay. The quiz is open book. Okay. is open book. So make sure that you have all your resources organized right before you start the quiz. Okay, so for me, I would make sure that I have all my assignment work, right? All the assignments that I've done, all my assignment work properly organized, make sure that that's all clean, probably highlighting any formulas that I've been using all along, right? And you can use that formula sheet that I posted, but I would encourage you to make your own, probably built around that formula sheet. And just make sure that you have everything, you've got your calculator and everything is just ready to go. Okay, so the quiz is open book. And so make sure your resources are well prepared. So no working together, but that I don't think that I should have to say that. Okay, and I know you think I won't notice, but I will know if you're working with someone. It's weird. I know you think I won't, but I will. I've got my ways. Okay. So anyways, good. So for the conditional probability, right, typically we're going to have two events, okay? And so we've got these two, typically we're talking categorical variables, okay? And so in this case, we're focusing on binary variables. Binary variables are the yes, no variables, right? They can be coded as 0, 1s. And that's what makes it binary. And so we only have two categories for each of the two categorical variables. Okay, so that's what we're focused on here. And we could have more, but that's what we're going to focus on. Okay, and so here we're talking about, so they did a survey of 792 teens, and we talked about what this data might look like. Right? Because we need to have that connection of, okay, if I see this type of data, what can I do to summarize it, right? But also one way to learn that is to think about, okay, this is a summary. So this contingency table is a summary. What would this data look like, right? So that we start to make that connection. So that's kind of where we ended off last day. And so we have 792 teens that we surveyed. And we asked them, hey, are you going to college immediately after high school? Yes or no? And then we're denoting that by this college variable, which I'm going to shorthand as just a C, right? So if it's C, it means that that high school student is going to college immediately after high school. Whereas the complement of C means that they're not, right? And notice that it has to be immediately after high school. Okay. And then the degree variables. So now if we look at the degree variable, we said that this indicates whether at least one parent of that teenager has completed a college degree. And so the follow-up question would be, probably how many of your parents have completed a college degree? Or has at least one parent completed a college degree? Okay, and so we are denoting that by D, just shorthand as D. And this is what I would encourage you to do, right? So read the question, figure out what the variables are, and then write out the shorthand. So here I'm saying let D mean at least one parent has a college degree, right? And let C mean that the teen went to college immediately after high school, right? Because now I can use these shorthands and it's going to make things a lot easier, right? And so D and C are events. Okay, so I think there were some questions that we wanted to work through. And what you're going to find is that everything that we're going to talk about here is outlined in these notes, but I'm going to kind of go off the beaten path a little bit in how I write them out. So, but it is all here. So all the examples that we're going to go through are all here. So if you wanted to read that instead, that's totally fine. So we're going to work through these, I think it's just 3 examples, and it's going to introduce us to conditional probabilities. Now, conditional probabilities, oh, I guess I haven't talked about it. Maybe, maybe I'll just do it up here. So a conditional probability is when the probability of an event is affected by whether another event has happened or not. Okay, and so, oops, and I have it written down somewhere, but let's just write it out here. So when the probability of an event depends on whether another event has happened or not, depends on, let's say, the outcome of another event. And I don't know why I capitalized event. That makes no sense. There. Okay. So what we're going to find is, or what we're going to ask ourselves is, okay, well, if I know that there's at least one parent with a college degree at home, does that affect the probability of that high school student going to college immediately after high school? Yes or no, right? And so now we want to consider these conditional probabilities. And so here, what you're going to find is that a lot of the time we can answer these questions just using the table, right? And so a lot of the time, if you read the question really carefully, and I think you've seen it on an assignment already, you have to read it so carefully, and it is really tricky. It's really hard to figure out what the question is asking, right? And so, but that's going to take practice. Right. And so, and then you'll start to notice the same type of wording over and over again, and then you'll become more familiar with it. Okay. And so, all of these questions we can answer with just the table, right? Or we can introduce some probability notation and some probability formulas that we could use instead, right? And so I'm going to show you both, but as long as you're able to answer the question, I don't really care how you do it. Okay, so I'm showing you both ways, and then you decide which one you want to use, which one makes more sense to you. Okay, so what proportion of teens, remember proportion is the same as a probability, and also kind of the percentage. So what proportion of teens have at least one parent with a college degree? Okay, so now we're looking at D, right? And so here we want to know, have at least one parent with a college degree. This is really just D, and the proportion is the probability, right? And so all we're looking for is the probability of D. Okay. So what we have is the degree variable. So we know we have to be in this column, the degree column. And it's 231 and 49, but that's split up by college, and there's no mention. We don't actually seem to care right now whether the student went to college or not, right? And so the total is going to be 280 over 792. Okay. So 280 over 792. You are allowed to convert that to a decimal. Okay. One word of caution is keep at least 4 decimal places. Okay. And if you're rounding, so 280 divided by 792, it is 0.353535 repeating. Okay. And I guess that's exact. But if I'm rounding, you should be denoting that by a tilde, or kind of an approximately equal, sorry. And that's just to remind yourself that, okay, I no longer have the exact value here. So unless you're keeping all your decimal places in your calculator, right, then you have to remember that your answers will be slightly off, right? And so we can round this to 0.3535, right? And what I'm going to say is, if rounding, keep at least 4 decimal places. Okay. I say at least 4 decimal places because if you're finding really, really small numbers, you don't want to write 0.00000 and then just be done with it, right? You want to capture some of the activity, right? So if it's really small, you need to up your decimal places. In this case, it looks like 4 decimal places should capture all the activity that I see here, right? And so I'm going to leave it at that. Okay. But if you're rounding just in general, keep at least 4 decimal places. And ideally, don't round at all. Okay. But I know that's kind of, that can be difficult sometimes, right? Sometimes we want to round, and that's fine. So what we're talking about here, when we only consider the values in the margins, well, then we're talking about marginal totals or marginal probabilities if we divide by the total, right? And so everything in the margins here are what we call marginal totals, right? Which we can convert to marginal probabilities. Wait, so these are marginal totals. Okay. Whereas these guys, we're going to call them joint probabilities. So for that reason, I'm going to call them joint totals, but joint totals. Okay. But basically everything inside the table, in the body of the table, those are the joint totals or probabilities. And then in the margins, of course, we have the marginal totals or the marginal probabilities, and that's just overall. So if I asked you what's the probability that a student goes to college immediately after high school, that doesn't specify whether there's a parent at home with a college degree or not, right? And so then what I'm looking at is the 445 out of 792, right? So we're always going to convert these to probabilities. Okay. So good. Okay, before I paste this in, I want to introduce the formula for conditional probabilities. So we need, let's see here. To calculate conditional probabilities, we need to introduce the formula. And I'll say a new formula. How about that? And it's going to be written like this. So the probability, oops, kind of zoomed in there, of A given B, and here I'm just going to write that this vertical bar is given. Okay, so the probability that A happened, right? So that this is the conditional part, right? So the probability of A happening given that B happened. Okay, so if you know that B happened, then what's the probability of A happening? If we think about it like, if I know that it snowed yesterday, what's the probability of it snowing today? Right, and so that would be a conditional probability. If it snowed yesterday, it's more likely to snow today, right? And so, and if it was 30 degrees out yesterday, it's more likely that it's going to be 30 degrees out today, right? And so, or warm at least, right? And so, right, whereas the probability, so if it snowed today, the probability that it's 30 degrees out tomorrow, unless you're in Calgary, is going to be very, very low, right? So it depends on what you're talking about, right? And so that's what makes them conditional probabilities. Okay, and so when we think about conditional, then that's when we're going to have this given, right? So given that B has happened, what's the probability of A? Okay, and so this vertical bar here is the given. Okay, and how we do it and how I remember it is it's going to be the probability of A and B, so whatever A and B are, divided by just the probability of B. So the probability of A and B divided by the probability of B. So you don't really need, I mean, in the beginning, you'll need a formula sheet, but eventually you're going to start to look at this and say, okay, if I need a conditional probability, the probability of A given B, then I'm going to take the probability of A and B and then divide it by the probability of B, which is the given part. Okay, and so that's how you derive this formula. What I also want you to notice is that this is how we're going to calculate the probability of A and B if the events are not independent, right? Or if we don't know. Okay? And so here, we will use this formula. This formula to calculate the probability of A and B, right? If A and B are not independent or it's unknown, right? If A and B are not independent or it is unknown, right? Whether they're independent or not. Okay? And so what we're going to do, all we have to do, right, is we have to rearrange and solve for the probability of A and B. How do we do that? We need to multiply the probability of B over to the left-hand side, right? And so what we're going to find is that the probability of A and B is the probability of A given B times the probability of B. Now, often I'll rearrange this, but if I'm multiplying, A times B is the same as B times A, right? And so as long as you have the given part is being multiplied by the probability of B, then you're safe. Okay. One thing to note is that here, note that if A and B are independent, then the probability of A doesn't care if B happened or not, right? So then the probability of A given B is just the probability of A, right? And so note that if A and B are independent, then the probability of A given B, A doesn't care about B anymore if they're independent. So then it's going to be the probability of A. Okay. And that's how we get, therefore, the probability of A and B is the probability of A times the probability of B. But notice how that's a special case, right? And that's only if A and B are independent. Okay. And so that's why the formula sheet that I posted is laid out the way that it is. And let me grab it. Maybe there. Right. So now we started here in the conditional probability section. Okay, so we have that formula and that's good. We can use it. And then the formula has been rearranged, solving for the probability of A and B. Now, for me personally, the fewer formulas, the better. I prefer to derive the formulas myself, right? So for me, I would probably ignore this one and just have this one and rearrange it to solve for whatever I want. Now, a lot of students don't feel that way, so that's why I have both on here, right? But if you're like me and you prefer to just have very few formulas that you manipulate and rearrange, then this one, this first one, the conditional probability, is the only one you need. Okay, but then the other one's been rearranged already, right? And so then notice that if A and B are independent, then we have this special case, right, of this general conditional probability. And so here, if A and B are independent, right, this is a special case of this, right? So that's just that's important to remember, right? So you don't want to be using that special case unless it applies, right? If A and B are independent. Okay, good. So how will we know if we have a conditional probability, right? Sometimes I'll be nice and I'll throw in the word given, right? Given that this has happened, then what's the probability of this, right? Then it's obviously a conditional probability, but that's not always the case. So let's see here our next example. Oops, didn't want to do it. So with practice, what you're going to find is that the hardest part, the very hardest part of these problems, these probability problems, is reading the question and translating it into something that you can calculate. That's hard. That's really hard. So here we're going to start to practice that. And then the calculations are relatively easy, right? And so here, given at least one parent completed a college degree, what's the probability that the teen went to college right after high school? Okay, so here, let's start to dissect this a little bit. So at least one parent completed a college degree. We've shorthanded that as D, right? What is the probability that the teen went to college right after high school? We've shorthanded that as C. So what are we trying? And then we have this very nice given, right? Highlighting, okay, this is a conditional probability. So knowing that at least one parent has a college degree, what's the probability of the student going to college right after high school? So if we had to reorganize this question, just with notation, right, we're going to try to solve the probability of C given D. Okay. if we map, and this is where, you know, it takes a lot of concentration and just practice, but this is where we map our general equation, right? Our general formula to the letters that we have, the events that we have. So then we're going to have this as the probability of C and D divided by the probability of D. Okay. The probability of C and D, well, that's easy. We can go back to our table, and maybe I'll make a copy and I'll do a fresh one here. And it would be easier if we had already converted these counts to probabilities, right? Which we could do, right? So that would make it a little bit easier. And I'm going to scoot this over so I can have it like that, have them kind of like this. But we haven't, so here we go. The probability of C and D, C and D is 231 over 792. So that's 231 over 792 divided by, and we already found the probability of D earlier in the question. So I always want you to be looking out for previous answers that you have already solved for, because that's often how I make the questions, is I kind of make them like a chain. Okay. And so making it easier to solve these big problems. Right. And so, but the probability of D we said was 280 over 792. So 280 over 792. Okay. Now remember, fraction divided by a fraction, you have to flip the denominator and multiply, right? And that's going to let us cancel that 792. So we get 231 over 792 times 792 over 280. And this 792 is going to cancel, and I get 231, oops, 231 over 280. Okay. Could I have found this using just the table? Yes, right? Because if I read this, right, so given at least one parent completed a college degree, that means I'm stuck here in this total, right? So all of a sudden my total is 280, right? Then what's the probability that the teen went to college right after high school? Well, that's 231 of 280, right? So here, I want you to notice we could have found the same answer by just reading the table. By just reading the table. But that takes practice, right? For me, I like to rely on the formulas, but if you prefer to just read the table and get the answer that way, that's great. You did it. Okay. So the last example that we're going to do for this one . Now we're going to mix things up and kick it notch. Given that it is selected and she did not attend college right after high school, so that's our given information. Okay, and how can we shorthand this? Well, a teen was randomly selected and she did not attend college right after high school. That's the complement of C, right? And so that's the given information. What's the probability that at least one of the parents has a college degree? So then what's the probability of D? Okay, so here, this is a very tricky one for me. if I am trying to use the table, right? For some reason, I just don't see it with the table. So then I'm going to rely on the formulas, but you can solve it with just the table, right? You just have to be careful. And I like to give you 2 ways to solve it because that way you can check your work, right? Does that answer make sense? Yes or no, right? And so what I'm solving for here is the probability of D given the complement of C. So now again, using that formula that we have, the probability of D and C, the complement of C, over the probability of the complement of C. So again, I'm going to use this here, copy, may as well, there. The probability of the complement of C, let's kind of start in the denominator, is 347 over 792. Whereas the probability of D and the complement of C, D and the complement of C is 49, right? And then the complement of C is 347. So what I'm going to have is the probability of D and C is 49 divided by 792. Divided by 347 over 792. Again, we've got a fraction over a fraction, so I need to flip the denominator and I need to multiply. So I get 49 over 792 times 792 over 347, which it's going to cancel, so 49 over 347, which is what you should have gotten if you were just reading the table. Right? Okay, good. So, right, because if I know that this student did not go to college right away, all of a sudden I've narrowed it down to only 347 students. Okay, and then what's the probability that they have at least a parent with a college, one parent with a college degree? Well, that's only 49 of 347, right? So you can use the table, but I find that it feels safer when I use the formula. Okay, so that's it for that example. The next thing I want to introduce you to is this idea of tree diagrams. So instead of having this kind of cross section of 2 different events, which can happen, right? Often we're going to consider consecutive events, right? And so in that case, we're going to find that it's easier to visualize with a tree diagram. Okay, so we will often need to solve problems involving consecutive events. Consecutive events. Okay. And so one way that we can solve these, and it's not the only way, of course, but the easiest way, I think, to solve these is to visualize them with a tree diagram. Okay, and so one way to visualize these problems, just to simplify them a little bit, one way to visualize these problems is to make a tree diagram. Yeah. Right, to help us solve these problems, I guess, but I'll leave it at that. Now, tree diagrams can be as complicated as you want them to be, or I'm going to focus on just a 2-branch tree diagram, and you'll see that it rapidly gets kind of out of control. And I'm going to focus on just 2 consecutive events. We can add on more events, but we're not going to go there in this course. Okay, so we're just going to consider 2 consecutive events, and what that's going to look like just in general. a tree diagram looks like this. Okay. We're going to start with the first event. So here I'm talking about some event A. Oops. Or kind of, so event A. A either happened or it didn't. A or the complement of A. Notice how event A only has two possible outcomes. It's possible that we could have more outcomes, okay, but we're going to focus on just two for the example. Now, I think there's a question on the assignment. I think the sock drawer one has more than two outcomes, so you'll get to see it. And the lactose intolerance one that I posted the solutions to has more than two outcomes. So, but for here, for introducing tree diagrams, I just want to focus on two possible outcomes. Okay, so A happened or it didn't happen. Okay, and what we're going to do is we're going to jot down below it with what probability, right? And so the probability of A and the probability of the complement of A. I'm going to bump these over just to center them a little bit more, a little bit better. Okay, so now so this is the first event. Event A is the first event. So it either happened or it didn't. Okay, then what I'm going to do, extend that a little bit. And then for the second event, event B, now I have a second layer of branches. So I often end up calling these layers of branches. And so now I have the second layer of branches, and that's going to be event B. Okay. Now, if A happened, B can happen or it doesn't happen. B or the complement of B. But then same thing, right? If A didn't happen, then B can happen or it doesn't happen. So notice again, B only has two possible outcomes in this scenario, right? Which we can expand these branches, but notice that if I start and I have 4 different outcomes for each event, what would that look like? That would look insane, like this: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You can do it. I'm going to erase that. That's messy. You can do it, but it's very complicated, but the ideas stay the same. Okay. So now B is going to happen with some probability, but it's conditional on A happening. Okay, so instead of just the probability of B, it's going to be the probability of B given A, right? Because I'm down the A branch. Okay, so my probability here is going to be the probability of B given A. Same scenario here, it's going to be the probability of the complement of B given A, and then the probability of B given that A didn't happen, and then the probability of B given, the complement of B given the complement of A. Now, if this notation is confusing, don't worry, I'm going to show you the simplified version, but I want you to see what's actually going on, right? And so one thing that I'll note here is that if B is independent of A, we can still use the tree diagram, but what happens? Then the probability of B given A is just the probability of B, and you just move on, right? And so what we're going to do is we're going to use this tree diagram, and we're going to find probabilities like the probability of A and B, okay, which is going to be the probability at the end of the branch. Okay, and so here I'm going to have the probability of A and B, which is from the formula, right? The probability of B given A times A, or the probability of A times the probability of B given A is fine as well. Notice that I'm just multiplying down the branch to find the probability of A and B, A and not B, not A and B, and then not A and not B. Okay. So at the end of each branch, I'm going to have the probability of A and not B. And I'm not going to write out the formula because all you're going to do is you're going to multiply down the branch. Okay. And so that's what makes it easier. And then the probability of not A and B, and the probability of not A and not B. Because I've considered all possible outcomes, the total of these probabilities, once you've found the values, have to add to 1. Okay, so total must add to 1. So that's a good way to check to make sure that you did it properly, right? And so, okay. So when we are finding ourselves saying and, then we're going to be multiplying, okay? If we find ourselves saying or, right? For example, what's the probability of B happening, right? In this general scenario? Well, B happens here in the first branch, but B also happens here in the second branch. So the probability of B is going to be the probability of A and B, or the probability of not A and B, right? So as soon as you catch yourself saying or, you're going to be adding those probabilities. Whereas when you say and, you're going to be multiplying those probabilities. Okay. And so here, if you say and, right, means to multiply, just as kind of a quick check-in. And if you catch yourself saying or, you're going to add. Okay. So I want to do an example, and I'm kind of running a little short on time, just enough time to do it. But I want to introduce the example for tree diagrams. And what I'm also going to show you is you don't have to have all this proper notation on your tree diagram. Your tree diagram is only meant to help you solve the problem. So as much as you need to solve the problem, and I'll show you exactly what you have to do. So, and I've picked a question that has kind of ambiguous wording just to help you kind of see through what's going on here. Okay, and so for tree diagrams, we commonly have to deal with consecutive events, right? And sometimes we can kind of tweak it and say, oh, I could treat these as consecutive events, but in general, they're going to be kind of one after the other. And tree diagrams are helpful in visualizing the probabilities and the combinations of outcomes. So the example is that 13% of students earned an A on the midterm, and of those students, okay, so that's a conditional probability, 47% got an A on the final. Here's where it gets kind of tricky if you really think about it. 11% did not get an A on the midterm, but got an A on the final. Okay. So the first part is build a tree diagram, labeling all the appropriate probabilities. So I'm going to show you exactly what you need to put on there. Okay. And so the first thing I'm going to do is I'm going to identify my two consecutive events, right? So first we write the midterm and then we write the final. And then I'm going to think about how many categories there are, but we really only seem to be concerned with, did we get an A on or not, right? And so first thing I'm going to do is I'm going to let it gets confusing because we talk about an A on the midterm and an A on the final. So I don't want to use A. You could use A and B if you wanted to, but that could get confusing as well. So I'm going to use M and F, ironically. So M, be the student got an A on the midterm. And I'm going to let F mean that the student got an A on the final. Okay. So that's the first thing that you want to do, right, is just figure out what your shorthand notation is. Next thing you're going to do is you're going to kind of think about how these events would unfold, right? And so here, the first event is the midterm, right? Either they got an A on the midterm or they didn't. Okay. And here's where I get sloppy, is I just write the probabilities underneath. Now, let's see here, 13% of students earned an A on the midterm. Okay, so I know that the probability here is 0.13. And so I don't use any proper notation or anything like that. I just jot it down below the event, the name of the event. And what does that mean? That means that 1 minus 0.13 must have not gotten an A on the midterm, which is what, 87%, right? 1 minus 0.13 is 0.87. Good. You always want to make sure, because otherwise, if you mess something up, it's not going to add to 1 in the end, and then it's all a mess, right? Then you have to start over. So always check your calculations. Okay, so then, right, then when I move on, so of those students who got an A on the finals, on the midterm, right, 47% of those students got an A on the final. So then my second event is either they got an A on the final or they didn't. And we're already given the conditional probability of 0.47, which means what? 0.53. And I am going to confirm that 1 minus 0.47 is 0.53. So that's good. So I already have that first branch, right? Or first set of branches. If they got an A on the midterm, then the possible outcomes are they got an A on the final or they didn't. Right? Same scenario over here, but the information that we're given is a little bit more cryptic. So they either got an A on the final or they didn't. Okay. It's not clear what they mean, but because of the information that we have, this 11% must be a conditional probability, right? And so here, whoops, sorry, that must have been loud. This must be a conditional probability, right? So the probability that they got an A on the final, given that they did not get an A on the midterm, the probability of an A on the final, given that they did not get an A on the midterm, must be 0.11, right? And that's just because I already know what percentage didn't get an A on the midterm, 0.87. So it can't be that, even though it kind of reads like it is, right? So just kind of work through that and kind of convince yourself of that. So then that's going to be the probability of getting an A on the final, but given that they didn't get an A on the midterm, right? Or sorry, I used A, I shouldn't, that doesn't make sense. There. I've probably mixed them up earlier too, but 0.11, and then 1 minus 0.11 is 0.89. Okay. So instead of writing out, because now I'm halfway there. So build a tree diagram. Okay, we did that. and then labeling all the appropriate probabilities. What I'm missing are the probabilities at the end of each of these branches. And what I'm going to do, instead of using proper notation, I'm going to get sloppy, and I always do. I'm going to say at the end of each branch here what the combinations are. MF, M not F, because then it's easier for me to just read across the branches and see what the outcomes are. Especially imagine if you have more than 2 consecutive events. Let's say you have 4 consecutive events, right? Then it's nicer to have all the different combinations at the end. Gets out of hand really quickly, but it helps. MCF and MC not F. So now I'm going to show that I'm multiplying down each branch, but I'm going to do that for each of the branches, and I'm going to jot down the probability at the end of each branch. Okay. And so here I'm going to show that 0.13 times 0.47 equals 0.47, 0.0611. Because it only gives me 4 decimal places, I'm going to keep all of those decimal places, because remember, it has to add to 1. If you find yourself having to round, maybe you have an irrational number and you have to round, then of course take that into account when you add up your total, right? Give yourself a little bit of leeway, but it should be very, very, very close to 1. Okay, so if I multiply down these branches, 0.13 times 0.53, I get oops, keep forgetting to switch to pen, 0.0689, and then 0.87 times 0.11, 0.0957, and then 0.87 times 0.89 is 0.7743. And just double check, if you add all these up, these are all the possible outcomes, and so they should add to 1. So I've got 0.7743 on my calculator, so plus 0.0957 plus almost mucked it up, 0.0689 plus 0.0611 is indeed 1. Okay. So now, this is all the work that you would need to show in order to answer this type of question. Okay. And so now, this is the hardest part. Building the tree diagram and finding those probabilities, that's the hardest part. Now I can use this tree diagram to answer the following questions. So what are those questions? What is the probability of a student earning an A on both the midterm and the final? Well, I have it here, so you're welcome to just put down 0.0611 and move on with your life. I'm going to show with notation what it is, right? But here, okay, so you can use the tree diagram. They have to have an A on the midterm and on the final. Okay, so there's only one branch that satisfies that, and that has a probability of 0.0611. Okay, and so what you can say is you can say the probability of M and F is the probability of M times the probability of F given M, which is 0.13 times 0.47, which is 0.0611. But really, if you're you don't have to show all that work. I'm showing it so that you have something to rely on, but you can just go straight down here, right? Or even if you said, you can say, or you can say 0.0611 from the tree diagram. Right, that's why we use the tree diagram, so that we can answer all these problems, right? So if you wanted to just say, okay, from the tree diagram, I see that it's 0.0611. Okay. Down to the buzzer here. Maybe I'll put this on a fresh page. Oopsies. What is the probability of a student earning at least one A on either the midterm or the final? Now, what I'm going to do is I am going to steal a copy of this tree diagram so that we can use it. And I'm going to erase this, and I'm going to erase this, and just bump this over. So at least one A. So that happens here. Well, because here I got an A on the midterm, and then I got an A. So that's two A's. Here I got an A on the midterm, so that's at least one A. Here I didn't get an A on the midterm, but if I get an A on the final, then I have at least one A. So the only time I don't have at least one A is if I don't get an A on either the midterm or the final, right? And so here, what you're going to say is, okay, the probability of at least one A is the midterm and the final, or the midterm and not the final, or the midterm, not the midterm and the final. Okay. So as soon as you catch yourself saying or, right, and maybe I'll kind of or, right, then you're going to add those probabilities. So the probability of at least one A is the probability of M and F plus the probability of M and not F plus the probability of not M and F. And maybe I shouldn't write the and, which is 0.0611 plus 0.0689 plus 0.0957, which is 0.0611 plus 0.0689 plus 0.0957, which is 0.2257. Another way that we could solve this is we could leverage the fact that they total to 1, right? And so if they have to add to 1, and I'm not interested in this one probability, and this goes for 1 or 2 probabilities, then I can just as easily lob that off, right? I can take that away, I can subtract it, right? Or what we can say, the probability of at least one A is 1 minus the probability of not M and not F, which is 1 minus 0.7743, which you can check, but it's the same. So you have two ways, you have many, many ways to solve these problems, and you should always end up at the same answer. And I know I'm out of time, but I am just going to grab the last pull because it's for some reason really easy. What's the probability of a student earning an A on the final but not on the midterm? Well, what is that? That's just the probability of not M and F, which from the tree diagram, not M and F is 0.0957. So we're done. Oops. Awesome. So make sure you have a look at those probability practice problems as well, just to see a bigger tree, a slightly bigger tree. But if you have any questions, let me know. Otherwise, good luck on the quiz this weekend, and I'll see you guys on Tuesday. And I'll stop this recording.